Most drivers either never use the parking brake at all or apply it incorrectly in ways that cause premature cable failure, seized rear brakes, reduced braking effectiveness, and potential vehicle rollaway accidents that cause thousands in property damage and serious injuries. According to automotive engineers and brake system specialists, the parking brake or emergency brake serves two critical functions: preventing vehicle movement on inclines and slopes, and maintaining rear brake adjustment on vehicles with rear drum brakes. Yet surveys show that approximately 60% of drivers never use the parking brake unless required, and many of those who do apply it incorrectly. The most common mistake is engaging the parking brake after the vehicle is already stopped and in gear on flat ground, where it provides no benefit and the brakes cool in an applied position. On automatic transmission vehicles, the majority of drivers simply put the transmission in park and consider the vehicle secured, relying entirely on the parking pawl, a small pin inside the transmission that locks the output shaft. And what most people don't know is that this small metal pin is not designed to be the primary vehicle retention device. It's a backup. Parking pawl failures cause vehicles to roll freely in parking lots, damaging other cars, property, and occasionally injuring people. Keep watching, because I'm going to explain the correct way to use the parking brake on different vehicle types, what actually happens inside your brakes when you do it wrong, why the parking pawl alone is insufficient, and the specific technique that prevents seized cables and worn components. Hey, if you like this kind of straight-to-the-point content with no BS, help me out here. Subscribe to the channel right now. It takes 2 seconds and guarantees you won't miss any tips that could save you some serious cash. Let me start with the most important mistake most automatic transmission drivers make: relying solely on the transmission parking pawl to hold the vehicle. When you shift into park on an automatic transmission, a small metal pin called the parking pawl engages a notched ring attached to the transmission output shaft, preventing it from rotating. This mechanical lock is effective under normal conditions on flat surfaces. However, it's not designed as the primary restraint system for several reasons. First, the parking pawl is a relatively small component that carries the entire weight of the vehicle on slopes. On a 10% grade, the force on the pawl for a 5,000-pound SUV is approximately 500 pounds of force concentrated on this small pin. Manufacturers specify maximum grade percentages for park engagement, and steep grades stress the pawl beyond its optimal range. Second, when you shift into park without engaging the parking brake first, the vehicle rolls slightly until the pawl catches, placing the full vehicle weight on the pawl. This makes it difficult to shift out of park afterward and stresses the pawl mechanism with repeated use. Third, parking pawls can and do fail. While not common, pawl failures result in the vehicle rolling freely despite being in park. NHTSA records include incidents of vehicles rolling from driveways and parking lots when parking pawls failed or were engaged improperly. The correct technique for automatic transmission vehicles is to engage the parking brake before shifting into park. Here's the exact procedure. Stop the vehicle completely. Keep your foot on the service brake pedal. Engage the parking brake fully before shifting out of drive. Now shift to park. Remove your foot from the brake pedal. With this sequence, the parking brake holds the vehicle before the pawl engages, so no weight transfers to the pawl. The vehicle doesn't roll onto the pawl. When leaving, you shift from park to drive before releasing the parking brake. Again, keeping weight off the pawl during disengagement. This procedure is specified in many owners' manuals and extends transmission life while preventing rollaway accidents. For manual transmission vehicles, the parking brake is even more critical. While leaving a manual transmission in first gear provides some resistance to rolling, it's not a substitute for the parking brake. Gear locking alone can fail if the clutch is worn, if the vehicle is struck, or on steep enough grades. Always engage the parking brake fully on manual transmission vehicles, regardless of terrain. Now let me explain why never using the parking brake causes brake failure over time. Rear drum brakes, which remain common on economy vehicles and are found on the rear axle of many trucks, use self-adjusting mechanisms that rely on parking brake engagement to maintain correct shoe adjustment. When you engage the parking brake, the rear brake shoes press against the drum, and an adjuster mechanism ensures they're positioned correctly for optimal contact. When the parking brake is never used, these auto adjusters can fail to maintain proper adjustment over time because they're designed around the parking brake mechanism being activated periodically. Improperly adjusted drum brakes feel spongy and require longer stopping distances. The vehicle may pull to one side during braking. Rear brake effectiveness decreases when drum brakes become severely out of adjustment. The shoes make poor contact with the drum, requiring the brake pedal to travel much further before any braking force develops. In extreme cases, you're essentially driving with minimal rear braking. Periodic parking brake use keeps the adjusters cycling and maintains proper rear brake adjustment as drum brake linings wear. Mechanics recommend engaging the parking brake every time you park as standard procedure to ensure this adjustment cycle continues throughout the brake's service life. However, there are specific situations where parking brake use can cause problems if done incorrectly. The most common mistake that causes seized parking brakes is engaging the parking brake after driving through water or washing the vehicle, then leaving the brake applied. Water trapped between the drum or rotor and brake component can rust or freeze the brake in the applied position. In cold climates, applying the parking brake when brakes are wet or slushy from winter driving can cause the brakes to freeze in the applied position overnight, leaving you unable to move the vehicle in the morning. The correct procedure for cold climates and wet conditions is engaging the parking brake only when you're confident the brakes are dry, parking in heated facilities when possible, or using the parking pawl alone in wet winter conditions on flat surfaces while accepting the minor drawback of not using the parking brake. Another situation causing parking brake problems is leaving the vehicle parked for extended periods with the parking brake applied. Extended periods mean weeks or months during storage. When brakes remain static in the applied position, corrosion can develop between the brake shoe or pad and drum or rotor surface, bonding them together. Attempting to release a corroded parking brake can damage brake components or stretch the parking brake cable. For long-term storage, it's better to leave the parking brake released and use wheel chocks to prevent movement. Now let me address parking brake cable maintenance, which prevents the most common parking brake failure mode. The parking brake cable runs from the handle or pedal in the vehicle's interior to the rear brakes through the undercarriage. This cable is exposed to road debris, salt, moisture, and temperature extremes. Without periodic use and lubrication, the cable housing fills with moisture, causing rust and seized operation. Regular use prevents cable seizing by keeping the mechanism moving and preventing rust accumulation. Mechanics recommend engaging and releasing the parking brake completely several times during regular washing to work the cable mechanism and prevent seized operation. Inspect the cable condition annually, looking for fraying, corrosion, or kinked sections. Lubricate cable contact points with appropriate cable lubricant every 2 years. A seized parking brake cable replacement costs $200 to $400 depending on vehicle. This repair is completely preventable with regular use and periodic maintenance. On newer vehicles with electric parking brakes, the maintenance considerations differ. Electronic parking brakes use electric motors to apply rear calipers rather than mechanical cables. These systems are typically more reliable and don't seize the same way mechanical cables do. However, they still require periodic use to maintain caliper function and prevent pad-to-rotor adhesion. The vehicle's system typically manages automatic engagement when parked or on steep grades. Follow manufacturer guidelines for electronic parking brake operation, as the procedure varies between manufacturers. Now let me address specifically correct parking brake procedure by terrain and situation. On flat ground, engage parking brake before shifting to park, or at minimum use parking brake in addition to park for backup security. Proper sequence prevents pile stress. On inclines or hills, always engage parking brake fully before shifting to park or leaving the vehicle. Turn front wheels toward the curb when parking downhill and away from curb when parking uphill, so if the vehicle moves, it contacts the curb as a secondary stop. On grades steeper than 15%, use wheel chocks in addition to parking brake for maximum security. For extended parking like airport lots, engage parking brake before shifting to park using correct sequence. For overnight winter parking in temperatures below freezing with wet brakes, use parking pawl only without parking brake if brakes are wet, using wheel chocks if available on inclines. For long-term storage beyond 2 weeks. Release parking brake and use wheel chocks instead to prevent cable seizing and brake bonding. So here's the bottom line. The correct way to use the parking brake is to engage it before shifting into park on automatic transmissions, protecting the transmission parking pawl from stress and preventing rollaway accidents. Never using the parking brake allows rear drum brakes to fall out of adjustment and allows parking brake cables to seize from disuse. Apply the parking brake every time you park on dry brakes. Avoid leaving the brake applied when brakes are wet in freezing conditions. Release the parking brake for long-term storage to prevent component bonding. Maintain cables with periodic inspection and lubrication. Regular proper use extends transmission life, maintains rear brake adjustment, and prevents the seized cable repairs that cost $200 to $400 to fix.